Hi, I'm Julie Ray, and I am here to talk about writing equations in the slope-intercept form. I'm going to share my screen with you so you can see what I'm talking about. And let's get it in full screen. Okay. So we're writing linear equations in slope-intercept form. And the app that I use to draw these, to create these graphs is called Desmos, Desmos. It's a graphing calculator that you can download and use either on a computer or on your phone. And it's really helpful in terms of visualizing what is going on when we're talking about linear equations. So let's take a look at some linear equations and a graph. So you can see that there are 4 different lines. They're different colors. They're rising or descending at different rates of change. This line is going down more steeply than this line. This line is rising more steeply than this line. So let's see if we can figure out what the story is behind these graphs. And that's an important concept, that the graph is telling you a story. And so we want to figure out, what is that story? So you can see over here, I have 4 different stories. They're very short ones, but they tell us a lot. So I have $200 and I plan to save $10 a week. Which line represents that story? So you can see on the graph here, the y-axis, which is the vertical axis, starts at 0 and goes up 100, 200, 300, 400, 500. So each one of these darker lines represents an increase of 100, but each one of these lighter lines here, there's 1, 2, 3. I'm going to count again. 1, 2, 3, 4, 5. There are 5 lines between 0 and 100. And so each one of these must represent 20, 20, 40, 60, 80, 100. Beautiful. The x-axis is increasing by 1, 0, 1, 2, 3, 4. And so each one of these lighter lines in between is going to be some part less than 1. So it's a fifth. There are 5 lines. So 1/5, 2/5, 3/5, 4/5, 5/5. Hey, Tishana.
Hi,
How are you?
I'm fine.
Good. So we're talking about graphing linear equations, and we're looking at 4 different lines here. And each one of these lines represents an equation. It also represents a story. So each one of these short little stories here corresponds to one of these lines. We're going to figure out which line goes with which story. So the first story is that I have $200 and I will save $10 a week. So if I'm starting with $200, which is the only line that starts here at the graph at 200, it's this red one. So let's see if we can also see if that represents saving $10 a week. And we had said that each one of these fainter lines here represents $20. So if this is 200, that's 20. Then halfway up must be 10. So if this is $10 every 1 week, down here, there's 1, 2, 3. So this graph increases by $10 a week. That makes sense. So this first one is this red line. Then this one says, I will save $50 a week. It doesn't tell us that we're starting with any amount of money. So that must mean we're starting at 0. This line starts at 0 and it goes up 20, 40, halfway up to 50. And there's your 1. So every week I'm saving $50. In 2 weeks, I will save $100. That makes sense. That means in 4 weeks, I should save $200. That makes sense. Okay. So this, I will save $50 a week, corresponds to this blue line. That represents what's happening. We making sense so far?
Yes.
Okay, good. So this next little says, I have $300 and I will spend $50 a week. So we know when we are spending money, we're not gaining it, we're losing it out of our account. It's disappearing, it's going away. So look at this line that starts at 300, and instead of going up, it's decreasing, which makes sense because if we're spending money, the total amount that we have will go down. So if I start at 300 and I spend $50 in my first week, then I should have $250, which this graph represents. By my second week, I should only have $200. So this is working out. This is where this graph is going. So notice that these two lines intersect right here. So the blue line is I save $50 a week. If I start with nothing and save $50 a week, I'll have the same amount of money as if I started with 300 and spent $50 a week. That's what that point of intersection is telling me. So I have $400 and I will spend $25 a week. Again, I'm starting with a certain amount of money, $400, and my line is going to decrease, go down, because I will have less money at the end of 1 week than when I started. So this represents going down $25 every week. And at the end of 4 weeks, I should have $300, which is what this graph is telling me. So this is what those equations look like. I have $200 and I will save $10 a week. If I'm going to write these in slope-intercept form, that means this is the form that I'm using. Y equals 10x plus 200. So I'm starting with 200 and I'm starting with 200 and I'm adding $10 every week. This one, I will save $50 a week. I'm starting with 0 and I'm going to increase by 50. Notice I don't have plus 0 here because that won't change my equation. So y equals 50x. I have $300 and I will spend $50 a week. So that looks like the 300. And then because I'm decreasing, notice that this rate of change here is negative. So I'm decreasing $50 every week. And we always, when we're working with linear equations, we're always reading our graphs from left to right. That confused me for a while because I said I could see that this was an increase, but that's not the way we read our graph. We read our graph from left to right. So this is a decrease because I'm going down as I go across the graph from left to right, which makes sense. That's the way we read books. And I'm starting at 0 and going to the positive here. So that would make sense that this is the way that would look. It looks like I'm going down the mountain. And then this one, I have $400 and I will spend $25 a week. Y equals negative 25x plus 400. So that's the form of the equation. And we'll get to that a little bit more detail in just a minute, but let's take a look at what this is telling us. We need to start at a certain number, and it can even be 0, and then change at a steady rate. That is what a linear equation is telling us, that I'm going to start somewhere, and then I'm going to add the same amount at a certain interval, a defined interval. That's what makes this graph look like a line, and that's why we call it a linear equation, because if we graph our equation, it will always make a straight line. It might be increasing, it might be decreasing, it might start above 0 in the positive area, it might start at 0, it might start in the negatives, but it will always look like a straight line. So I've been making masks for my family to wear outside. And one day I had several people who had asked me for some. I was trying to figure out, well, how long will it take me to make these masks? I've already made 6, and I've determined that I can make 3 masks in an hour.
Because I thought I was at this morning already.
Do you have a question?
Oh. Oh.
So if I have already made 6 masks and I can make 3 masks in an hour, how long is it going to take me to make 10 total masks? Well, I would.
She's in the meeting with somebody. So she knows that I'm, but I don't know how to.
Do you have a question?
Why won't go? Yeah, but I made a mistake and went too far back and I don't know.
Is everybody okay? Because I'm hearing someone talking, but I don't think you're asking a question. Okay.
I don't know what's going on with the laptop. Can't get back to it.
Okay. So, how long would it take to make 10 masks? If I came up and looked, this is my time in hours. It would take me an hour and a half to get to 10 masks. If I needed to make 20 masks, I'd come over here and look. Here's the 20 masks. It would take me 4 hours and 40 minutes to make all those masks. Okay, so this is what it's telling me. I'm starting at a certain number, and then I'm going to change at a steady rate. I have driven 50 miles, and I keep driving at 60 miles per hour. I'm going to start at a certain number, 50 miles, and keep driving at a steady rate. So 60 miles every hour. Notice over here, it tells me time in hours. And this is my miles driven. So I'm going to go start at 50 right here and go up 60 miles. And I would be able to tell you in 3 hours, how far have I gone? In 4 hours, how far have I gone? In 5 hours, how far have I gone? Again, we're going to start at a certain number and then change at a steady rate. It's 25 degrees. The temperature decreases 2 degrees every hour. So if I start at my number 25 and then I go down 2 degrees, what will the temperature be in 5 hours, in 6 hours, in 10 hours, in 13 hours? And so I can look at this line and it will tell me at any given point or what the temperature will be, or if I know the temperature, what time will that be? So I can look at it either way. Notice that because this is decreasing, our line is decreasing, going down in this direction. So that would be a negative slope. My truck is empty, so I'm going to start at 0, and each bag of multi-load weighs 40 pounds. So every time I'm going to go up 40 pounds for every bag. Here's my bags. In my way, there you go. They're the bags that I've loaded. And there we go. They're the bags that I have loaded. And this is my total weight. So with every bag, how much does my total weight increase? That's my steady rate of growth right there with each bag. So here's one where we're starting at a negative number. I owe $50. I can pay back $5 a week. So I'm starting down here in the negatives. There's negative 50. And then every week I can pay back 5. Here's my graph. Notice that this is going up by 2s. So here's 1, that's 2, that's 3, and these are my weeks. No matter where I put this, it's in the way. That's better. So they're my weeks over there. And this is my dollars on the y-axis. This is the x-axis. This is my y-axis. So I'm starting at 50 and I'm going to pay back $5. Well, in 1 week, I would only owe 45. In 2 weeks, I would only owe 40. In 3 weeks, I would only owe 35. So we're starting at our number there and increasing how much we've paid back, decreasing how much we owe. Okay, but because we're looking at total dollars paid, it's a positive slope. Starting in the negatives, but we're going towards the positives. What I'm looking for is, when does this equal 0? This y-axis. When does this y-axis equal 0? That means I finished paying back everything in 10 weeks. And that makes sense. If I owe $50, it will take me 10 weeks to pay it back at $5 a week. So this is what I want you to be looking for in terms of a linear equation. I know I am repeating this, but it's to help you see the pattern, because math is based in patterns. The pattern for a linear equation is that you're going to start with a certain number and then you're going to change at a steady rate. So there are all kinds of scenarios where this could happen. Doing it with money makes a lot of sense. That's a lot of the problems will work with that. So let's take a look at these. I have made 6 masks. That's my number that I'm starting at. I can make 3 masks an hour. That's my change at a steady rate. I have driven 50 miles. That's the number that I started at. I keep driving 60 miles per hour. That's my steady rate. Every hour, 60 miles. 60 miles per hour, that's my steady rate. It's 25 degrees. That's my number that I'm starting at. And my temperature decreases 2 degrees every hour. That's the change at a steady rate. My truck is empty, so I have 0 bags in there. That's the number I start with. Each bag that I add weighs 40 pounds. That's my change at a steady rate. So that steady rate of change is my slope. Starting point is my intercept. And that's why this equation is called the slope-intercept form. There are different ways to write a linear equation. The slope-intercept form is just one of them. And it's called that because the key factors that we're using are the y-intercept, the place where we're starting, that starting number that we have, and the slope, the steady rate of change. If we know those 2 things, we can answer that equation. We can give the facts about that equation for any point on the line. And what I mean by that is, this is what I was just talking about. So the slope-intercept form is y equals mx plus b. That's the formula for the slope-intercept form of writing a linear equation, where the slope is your change at a steady rate, and it is indicated by the variable m right here. That's the slope. The b in this equation is the intercept. It is the starting point on the y-axis, and that is the b. So there is actually an x-intercept in a linear equation too, where the line crosses the x-axis. But in this case, when we're talking slope-intercept, we're talking about the y-axis. We're talking about the y-intercept. I know the y-intercept, my starting point, and I know the rate of change. I can find any point on the line. So here's this equation again. Let me do this again because now it's in the way. Y equals mx plus b. So this x and this y are the coordinates of a point on the line. They can be the coordinates of any point on the line. That's why they variables in this this form of the equation, because they could be any point along the line. There are times when we want to find a specific point, and then we can do that, and that will be what we talk about probably on Wednesday. So M is the slope, the rate of change. B is the y-intercept, the starting point. So here's the graph. And I made this graph with Desmos. You can see it down here, Desmos. And that you can access. It's a website that you can use on your computer. It's also an app you can use on your phone. It's very easy to use. They also have some videos that explain how you use it. And we're going to play with it a little bit here in a minute. But here's my equation, y, x. That's any point on the line here. Any point, it doesn't have to be a whole number. It could be a fraction. Any point along here is represented by this equation. The 5, remember the slope-intercept form is y equals mx plus b. So the slope is the m variable. In this case, that's 5. It's positive 5. That's why our line is increasing. It's rising, going up, even though we started at negative 50, represented right here by this minus 50. We could have also written this as plus negative 50 if we had wanted to. But that tells us that our y-intercept is a negative number, negative 50. So here's what it looks like. Negative 50, starting point here, and then going up by 5. Now let's look. This dark line here represents 2. That means each one of these lighter lines represents 1/2. So this is 0, 1/2, 1, 1.5, 2. So this line right here represents 1. So we're starting at negative 50. This is negative 40, so this must be negative 45. So my slope is telling me go up 5 over 1. And even though there are 2 lines here, we have to recognize that it means by 1, and this would be 1/2 if I stopped here. So I have to go all the way over to here. So this is up 5 over 1. Up 5 over 1. Up 5 over 1. That tells me if I wanted to put in this point right here, which would be negative 45 for the y and 0 for the 1, for the x, excuse me. So that point is 0, negative 45. If I substituted that in here in this equation, what would I get? Let's look at that. So thinking about this point, where we have our slope is 5 and our y-intercept is negative 50, and I substitute in the point 0, negative 45, this is what I would get. And actually, that's not a point on the graph. I am so sorry. Let me go back. Whoops. That's 0.50. It would be 145. So if I substituted that in, where did I go? this would be what the equation looks like. 1 is the x and negative 45 is the y. So that's the point after 1 week. 1 week, I would owe negative 45. Let's see if that makes sense. If I simplify this, I would get 5 minus 50. Well, 5 minus 50 is negative 45. Okay, so that's what this is telling us, that if I know any one of those x's, I can find a y. That's kind of a leap ahead to tell you where we're going. But let's take a look at this a little bit more. So if you know the y, you can find the x. And if you know x, you can find the y. If you draw the line, you know all the points that make the equation true. That's what a linear equation is all about. It's helping you find what points make the equation true on that line. So let's go to Desmos.com. It takes but a second to download this on your phone. I would like for you to just follow along. Notice that I'm at Desmos Calculator, and that's the first thing that pops up. So if you just click on that, you would be at the same place I am. So y equals, I'm going to start with 5x plus 2. So notice how quickly that graphs the line for you. It's kind of amazing, isn't it? Let's look at that line. You know what I want to do. Okay, look what happens if I make my slope negative. See how it goes from increasing to decreasing. I'm going to change that back. And I am going to, you're in the way again. I am going to go in a little bit. There we go. Watch what happens when I change the y-intercept. See how it jumps up? But change it again to 5. See how it moves the line right up here? Notice that's giving me the coordinates of that particular point. Let's see if I click here. It gives me the coordinates of that point. That's cool too. Look at this. And notice how I told you that there is an x-intercept and a y-intercept. That's the point that this graph is telling me right here. It's highlighted because those are very critical points in a lot of cases. Here's the y-intercept. I know it's the y-intercept because x equals 0. So it's where the line crosses the y-axis, and look, here's x equals 0. So that when x is 0, that will tell me that that point is the y-intercept. Look here, y equals 0. That tells me that's the x-intercept. So those are two critical points for many cases when we're using a linear equation. Let's make another equation. Notice I would just go right up here and I'm going to hit that top one, which says f. That means a function. It's an equation that is a function because for every x, there is only one y. That makes it a function. So y equals, I'm going to do a slope that is a fraction because we see that a lot. 1/2. Notice, there we go. 1/2 x. If I don't put a y-intercept in, it goes to 0, which is what it should do. And then my slope is 1/2, so I'm going up 1 over 2, up 1 over 2, up 1 over 2. And that's my slope is 1/2. If I add a y-intercept, watch what happens. My line moves up the y-axis. If I change this to -2, it goes down the y. Where'd you go? Oh. It goes down the y-axis. Okay. Do you have any questions about what we're doing here?
No, I'm trying to get the hang of it. I think the more and more I practice with this, the better I can get at it.
Okay. Do you have can you download this app?
Yeah.
Give it a try. And one of the things that I think really helps you see what's going on is when you make those changes and watch what happens to the line. So what do you think will happen to this line if I change the 1/2 to a negative?
Which line? It would be a negative.
Yeah, this blue line. What do you think will happen to it if I make that slope -1/2?
It would be the line would be going down. It would be decreasing.
Beautiful. Exactly. That's what happened. Great. If I change this to plus 4, where will the line go?
Which line? The blue line?
The blue line. So that's
If you
the B.
change it.
That's a starting point. It's going to move up the y-axis so that it's at 4. So it crosses the line at 4. And notice I'm calling
Okay.
a starting point, and yet the line keeps on going over this way. And that's because I haven't told it. I can actually say,
One second.
yep, Tayshawn, are you still there?
Yes, I'm still here.
Okay, how's this going for you?
Um, hmm, we can go. We need to probably practice some more.
Yeah, okay. So does the idea of understanding that you're kind of telling a story and it's got a starting point and then you increase by a steady rate, does that part make sense?
Yes.
Okay. So then does the part about like if you have this line, you can say what's going to happen at any
I'm back.
point.
My daughter has prayers.
Oh, that's fine. Does that part make sense? Line is telling you where you can be on any at any particular, you can find the answer to any particular situation that you have. Does that make sense, Tayshana?
Yes, it does.
Okay, cool. Then we're in the right direction. So where do you think you're struggling?
I want to say, hold on, wait, let me make it a little bigger. The negative half x plus 4.
Okay, so here's the let me get back to what do I want to get back to? I want to get back to I am sharing. Okay, let me get rid of this. And what happened to my drawing tool? Oh. Okay. So here's the starting point. That's the 4. Okay. And I changed this to say in Desmos, oh, good grief. I changed this to say start my graph at 0. Okay, this is where I told it to do that. X is has to be greater than or equal to 0, and it ran off the graph at 17.59. I could change this as well. I can make this say 10. But actually, I kind of liked it better the other way. Okay. So here we are at 4. Now notice this is 0 right here. 1, 2, 3, 4, 5. Here we're starting at 4. 1, 2, 3, 4 right there. And my slope, so that's my y-intercept. I'm at 4 on the y-axis. This is the y-axis up and down here. And I am, oh, I like that better there. I am going to start at 4. And this slope tells me to go down 1 and over 2. Do you remember that part about slope? That it's always the rise, the y. It's
The rise
changing.
over the run.
It's rise over 1. It's change in y over your change in x. So this represents the y. This represents the x axis. So we're going to go down 1 and over 2. And there's my next whole number point. Every speck on this line represents a point. It could be, it's going to be decimals, 1.1111, something like that. This is a continuous line, but this is the whole number point where it represents what number on the x? 1, 2. What number on the y? 1, 2, 3. So this point right here is 2, 3. It would help us out if we had more numbers here. That's the one thing I don't like about this Desmos, is that I can't, it's awkward to make it tell you every single number. But if I go down 1 and over 2, here's another point represented by whole numbers. The X is 4, the Y is 2. Down 1, over 2. Down 1, over 2. So if, yeah. If I put, what point is this right here? On the x-axis, it's 1, 2, 3, 4, 5, 6, 7, 8. It's not going up or down on the y, so that's 0. So this point is 8, 0. If I substituted that into this equation right here, y equals 1/2 x plus 4. If I substituted that point into this equation, this is what I would get. Okay, stop sharing here. So y, that's my equation, y equals negative 1/2 x plus 4. If I substituted that point in, I would not get 4. I would get 0. That point is 8, 0. Is that true? What's negative 1/2 times 8?
Times 8 is negative.
What's half of 8?
Is it
Half
negative?
of 8 is, yeah, so that's negative 4. So
Okay.
0 equals negative 4 plus 4. Is that true?
Yeah, because if you go to number line and you go to -4, you add 4, it'll land at 0.
Yeah. So that point, 8, 0, notice that it is, this is the X value. See it right? Oops, right there. This is the Y value for that point, the Y coordinate right there. That's what it's substituting in for. So this point on that line is 8, 0. Those are the coordinates of that point, and it makes this equation true. That's what this is all about, is being able to find the coordinates of any point on the line that make the answer true. So let's see, what could the story behind this equation be? Y equals negative 1/2 x plus 4. What could we be talking about? Notice in the examples that I gave you, we talked about money, we talked about face masks, we talked about loading bags of mulch. Give me an example. Oh, I know what this could be. I have 4 cookies. And if I eat half a cookie every hour, how many hours before I don't have any more cookies?
1, 2, 2 is the answer
Well,
2.
no, the answer is not 2. So I'm starting with, let me go back. I'm starting with 4 cookies, and every hour I eat a half of a cookie. I've eaten a half of a cookie
So you
at,
have 3.
whoops, there we go. Half of a cookie at 1 hour. Now I have 4.5 cookies. Half of a cookie in 1 hour. Now I have 3. And I keep going.
So that's one cookie per hour.
One cookie for every 2 hours. One cookie every 2 hours. One cookie every 2 hours. Because I'm only eating half an hour and I'm going down. Well, in 8 hours, I will have eaten all 4 of my cookies, right? And I will have 0 cookies. So that's what this is telling me. How many cookies will I have left in 5 hours? Well, what number is this right here? 1.5. I'll have, in 5 hours, I'll have only 1.5 cookies left. What about in 6 hours? How many will I have? 1 cookie. How about in 7 hours? A half a cookie. In 8 hours, 0 cookies. Okay, so that is what the linear equation is telling us. So notice here in this one, y equals 5x. I'm starting at 0. So if I can, what could I do? What could I do? I could earn $5 an hour, which would be kind of sad, but I could earn $5 at 1 hour. I would have $5.
Okay.
In 2 hours, I would have $10. Yeah, but I could also say, how much money would I earn in 1.25 hours or 1.5 hours? So I could, any point on this line, I mean, if I worked for someone who would pay me by the minute, I could say, you know, how much money would I make in 1 hour and 12 minutes? Or if my pay was $5.65, you know, I can go up by any amount. That's why this line is continuous. I can find a number anywhere on here. If I wanted to know how much money I would make in, let's see, what point would this be right here? 1 hour and 11 tenths, not 11 minutes, but 11 tenths of an hour. I would make $6.27. What about like right here? In 2 hours and 84 hundredths of an hour, I would make, 84 thousandths of an hour, I would make $11.77. Well, and they round it up, so $11.78. So anywhere on this, look, it changes as I slide all the way down. For every single little infinitesimal point on this line, I can say what the answer is if I'm making $565 an hour. If I had an employer who would pay me by the smallest amount of an hour, I would know exactly to the thousandths of a penny how much money I would make.